Hello everyone, welcome to our webinar introducing MecSoft's Cad Cam products today. My name is Anita Anand and I'm the VP of Sales at MecSoft Corporation. I have with me here Uday Honalagure, our support manager, who will be running a demonstration of our CAM solutions for you. We also have Joe listening in and helping out with questions in the back. So we have a lot of help here, and I'm hoping we have a great webinar with a lot of questions and a lot of information that we can share with you. Next. Uday, next slide. Before we start, here are some housekeeping tips for you. We are recording the webinar today and we'll make it available to you in the next couple of days as soon as we clean up and make it and publish it. During the webinar, feel free to use the chat window shown here below, the red arrow. Post any questions that you might have. We will be responding in that same window and answer your questions during the hour. You will see the response in that same area there. We also have reserved the last 10 minutes for questions, so there will be plenty of time to answer them. Any unanswered questions, though, will be responded to via email. You are also welcome to contact us email or phone with any questions that might pop up after the webinar. Next, Uday. Now, the agenda for today, we will cover an introduction to the MecSoft products, highlighting our CAM solution. Now, we offer a standalone CAM, Visual CAD CAM, and also plugins for Rhinocam CAD, Solidworks, a Libra, and the cloud solution Onshape. We have different modules, the mill, turn, nest, a G-code editor, as well as profile nesting. We also include CAD modeling, 2D, 3D, art, and mesh. Towards the end, I will cover details on support and sales. And let's see, the next slide, please. Now, who are we? We build and market state-of-the-art computer-aided manufacturing CAM software solutions for computer numerical control manufacturing in a wide variety of industries. As you can see, aerospace, automotive, production, music, woodworking, jewelry, mold and die, prototypes, robotics, and we have a very strong customer base in education as well. This is our 22nd year in providing powerful yet easy to use CAM solutions that offer outstanding value. We know CAM and we can be your CAM partner. Next. We are also very proud to have a strong customer base, over 10,000 customers in about 50 countries over the world. We play in small shops, entrepreneurial shops to Fortune 500 companies. We have loyal, passionate, and repeat clients. As you can see, we have a lot of big names: NASA, Apple, GM, Louis Vuitton, Tiffany, GE, Panasonic, a lot of customers, repeat customers. And as I mentioned earlier, educational customer base is pretty large. Speaks about our product that is really easy to use. Next slide, please. Now, the CAM solutions we offer, we go all the way from CAD, mesh, mill, turn, nest, art, and a 3D print module. Our first product that we released is a standalone CAM solution. It's the Visual CAD CAM product, includes CAD, and can be purchased with all these modules. It includes the mill, turn, nest, and art module, mesh, and 3D print can be added on. CAD goes with it as well. Now, the Rhinocam product is nothing but Visual CAM with a plugin to run fully integrated in the Rhinoceros design CAD system. It includes all the modules, just as with Visual CAD CAM, and it is used for advanced machinists desktop product. Similarly, we have Visual CAM for Solidworks, which is a completely integrated solution inside of Solidworks. Includes mill and turn module. It is desktop and again used for advanced machinists. We also have a plugin for a Libra design. Includes the mill and turn modules for machinists, a desktop product as well. Now our cloud-based solution, which is integrated with Onshape, is something that we've released a few years ago, which is also available for you to use. It includes just the mill module as of now. Next slide, please. At this point, I will have Uday come and demonstrate our CAM solution. And here's Uday Hanalagre, our support manager. Take it away, Uday.
Thank you, Anita. Hello, everyone. Good morning, good afternoon, or good evening to you folks, and thank you for joining us for today's webinar. We will be demonstrating all our CAM solutions today, and starting with our flagship product, which is going to be Visual CAD CAM. Visual CAD CAM is our homegrown flagship CAM solution, which runs inside our homegrown CAD product called Visual CAD and runs off a plugin architecture. This product allows you to import files from a variety of different CAD systems. You can bring in files of type IGESTEP, STL, DXF, DWG. A wide range of file formats are supported. In addition to it, Visual CAD offers you several different CAD modeling tools, starting with curve modeling, surface modeling, solid modeling, mesh modeling as well. Visual CAM runs using a plugin architecture, and there are several modules that we currently offer inside of Visual CAM. Our mill module offers 2 to 5 axis milling solutions and is offered in different product configurations, starting with Express, Standard, Expert, Professional, and Premium configuration. Turn module can be used for programming 2-axis CNC lathes or turning centers. We have a module for mill turn. Profile nesting is to nest profiling toolpaths. G-code editor module allows you to bring in your NC file or ISO G-code file, and you can run a verification toolpath backplot as well as cut material simulation. Mesh module offers mesh editing, mesh repairing, mesh healing. You can also go from point cloud to mesh, which could be used for both subtractive manufacturing, which could be a CNC machining process, or an additive manufacturing process like 3D printing, where you can also add supports to it and generate either a G-code output or output as an STL file. Nesting allows you to do nest parts into a sheet called parts nesting, and art module can be used for taking raster, converting raster to vector geometries, also creating 3D reliefs from raster images. So I have the mill module selected, and as you select the mill module, it displays the Visual CAM interface. It's docked over here on the left side. You have the program and the simulate tab over on the top right, and the machining objects browser provides you access to tools, machining regions, features, and knowledge bases. Once you have your machining operations program, you could go and run a cut material simulation, right click and simulate. That gives you a cut material simulation in Visual CAD CAM. Visual CAD CAM offers you a wide range of methods, starting with 2-axis methods. You have from roughing, facing, pocketing, profiling, V-carving, engraving, slot machining, chamfering, filleting, hole pocketing, profiling, T-slot machining, knife cutting, and remachining. Under 3-axis, we offer several different methods, starting with roughing, re-roughing, different types of finishing methods, parallel, horizontal, projection pocketing, offset pocketing, advanced 3D methods like pencil tracing, remachining. We also have radial, spiral machining, curve machining, between two curve machining, and reverse post machining. We also offer multi-axis toolpath with 4 and 5-axis methods in our Expert, Pro, and Premium configurations. You can do 4-axis, both indexed as well as continuous 4-axis methods. and simultaneous 5-axis toolpath method offered in our premium configuration. Hole machining is offered in all of our configuration. We have drill, tap, bore, reverse bore, and 4-axis drilling methods are also offered. Now, this plugin is great for users who would like to bring in their own CAD files. They have their own CAD system, bring it in and generate toolpaths by importing their file. And if you need to make any small modifications in terms of adding geometries, that'll help the machinist in easily creating toolpaths without having to go back to the host CAD system to make design changes. So this would be our flagship Visual CAD CAM product. Now, the next product I'm going to be quickly going over would be our plugin for Rhino. This is called Rhinocam. And Rhinocam is fully integrated into Rhinoceros 6, the latest version of Rhino, as well as it runs in Rhino 5 64-bit. The functionalities of Rhinocam are identical in both Rhino 6 and Rhino 5 64-bit. And you can see the interface inside of Rhino. There's the pull-down menu bar for Rhinocam and the same modules that we talked about earlier in our CAM products. And the machining browser is over here on the left half of your screen. You have your program and the simulate tab. And as you program your toolpaths, the operations up here are listed in the list. And your workflow typically for programming is working your way from left to right as you work through each of these groups. So I'm going to run to the simulate tab, select an operation, and click play to run a cut material simulation inside of Rhinocam. So this is the integrated CAM solution for Rhinoceros CAD, works in Rhinoceros 6.0 as well as Rhino 5 64. And all of the modules we talked about earlier are also offered inside of Rhino in Rhinocam. Now, the next product I'm going to be talking about is our plugin for Solidworks. Visual CAM for Solidworks is our gold certified CAM product that runs completely integrated in Solidworks, versions 2011 to the latest Solidworks 2020 version. Once you have your Visual CAM plugin for Solidworks installed, you will notice the Visual CAM 2020 tab appearing in your command manager in Solidworks. You can also notice this under your tools, Visual CAM 2020 drop-down menu. The Visual CAM's machining browser appears as a tab right next to your feature manager design tree, and you can always switch back and forth between your design tree and Visual CAM, so you could make design changes and continue programming. So this is our CAM solution for the parametric CAD, which is Solidworks, Visual CAM for Solidworks. Again, it's a gold certified CAM product, works completely inside of Solidworks. The workflow would be very similar, working our way from left to right as we work through each of these groups under the program tab. Once you have your operations programmed, you can run a simulation by right-clicking and simulate to perform a cut material simulation inside of Solidworks. So as you can see here, the display, the toolpath simulation is completely integrated into your Solidworks interface. So milling, turning, profile nesting, and G-code editor modules are offered in Visual CAM for Solidworks. So the next parametric solution I'm going to be talking about is going to be a Libra Camp, which should be an integrated CAM solution for a Libra design. And this works in the latest version of a Libra design, which would be a Libra design 2021. It also works in a Libra design 2019 as well. So as you select the add-ons tab and click on Libra Cam and Mill, the Libra Cam interface appears directly inside of a Libra design, and you can always switch between your Design Explorer and a Libra Cam by toggling the tab down at the bottom of your screen. Again, you have the machining browser interface at the top half of your screen and the machining objects browser at the bottom half of your screen, where you can define different types of tools, starting with ball mills, flat mills, corner radius, tools for engraving, chamfer, taper, thread mills, face mill cutters, lollipop cutters, fillet mill tools, a wide range of tool types, including drill, center drill, reamer, tap, bore, and reverse bore are offered in a Libra Camp as well. So the workflow would be very similar, work our way from left to right as we program through each of these groups. And then when you're ready to simulate, switch over to the Simulate tab, click on the simulation window, and then select Play to run your cut material simulation within a Libra Camp. So Libra Camp offers several different modules for milling, turning, profile nesting, and G-code editor as well. And it's completely integrated inside of a Libra Design, the latest version 2021, as well as works in a Libra Design 2019. The next product I'm going to demonstrate here is going to be our cloud-based solution, which is going to be Visual Cam C for Onshape. Onshape, which is now part of PTC, is a fully cloud-based CAD solution, and Visual Cam C runs completely inside of Onshape on the cloud. So you could be running this on any operating system. It could be Windows or Mac or Linux. Runs on a browser. So you can basically run Visual Cam C by selecting Add Application in Visual Cam C. Now what we are looking at here is an assembly, and I'm going to be loading one of the parts from an assembly here. And you can program parts using Visual Cam C by selecting Insert an Element, Add Application, and Visual Cam C, and this will load up the Visual Cam C as a new tab inside of your Onshape's document in the browser window. So Visual Cam C is a fully integrated CAM solution for Onshape and currently offers the milling module, where you can program 2- and 3-axis toolpath operations, and in addition to hole machining and drilling operations inside of Visual Cam C. Now this module also provides you with cut material simulation on the cloud, with, in addition to your toolpath animation. So you could be programming parts by loading parts from your part studio in Onshape and generating your toolpaths. And as you can see, it's completely being done on the cloud. There's no installations required, runs off of your browser. So we have your toolpath stock model. The toolpaths generated for different operations, offers a wide range of methods in 2-axis, 3-axis, hole machining, and I'm going to select the setup, right-click, and pick Simulate to run the cut material simulation in the cloud. So this is Visual Cam C for Onshape. Okay, folks, now I'm going to give you a demonstration of our toolpath methods that are offered in different configurations of our product. And I will be starting out with our Rhinocam solution here to show you how we can generate toolpaths. So I have this guitar body that's loaded inside of Rhino. This could have been modeled inside of Rhino, or you could be modeling it in your CAD system. So the typical workflow in here is once you have the part imported or modeled or loaded, you would want to go into your Program tab in the machining browser. The first step is to define your machining process. You could choose whether it's going to be 2, 3, 4, or 5 axis. For 2 and 3 axis, we would leave it as 3 axis. In the next step, we could select the post processor, a Rhinocam's mill module, and all our mill modules offer you over 300 plus different posts, which covers a wide range of machine tools that are available out there. So we could select the post processor, either they're listed by the name of your machine tool or the controller, or a combination of the two. You can set your posted file extension, and then we'll go ahead and define our stock material in here, the size of the workpiece of the blank you're going to be starting with. Then specify the thickness of your stock material. As you define the stock is created and displayed in the viewport. In the next step, we'll align the stock to the part. The stock is now aligned to the part geometry. And then we can pick the material that you're going to be cutting. In this case, I will be picking wood, or you can select other material types from the list. You can also apply a texture of the material for simulation. Then we'll define our work 0, also known as work coordinate origin or program 0. So I'm going to pick the highest Z southwest corner. Now I could load a library of tools as I've already done here, or I can create tools as I go through creating the operations. And Rhinocam and all our CAM products support all of these different tool types, starting with ball mill, flat mill, corner radius, engraving tools, chamfer, and of course, the tools for hole machining and drilling. These tools can also, you can set the feeds and speeds and save the feeds and speeds along with each tool into your tool library. There's also a built-in calculator available to establish feeds and speeds. The next step, we'll start programming our operations. I'm going to start with a facing operation. We'll pick a tool for facing. We'll specify feed speeds, the clearance, and then we'll go into cutting parameters where you can specify the cut pattern, the cut direction, the step overs, and then pick generate to compute the toolpath. So the facing operation is done generated. The toolpath is previewed on the model. We will now go to the simulate tab, run the computer simulation. You can always pause and run through the simulation. I'm now going to go ahead and program the pockets using a pocketing operation. We'll pick these two pocket boundaries, specify a tool for it, and the workflow remains the same. Setting up your parameters, cut levels, and then generate, create your toolpath for pocketing. There's our pocket toolpath. I'm going to go ahead and program these open pockets using facing. Using the same tool. And then finally, I would do a profiling operation to relieve the part from the stock material. I can either select face edges, a pocket boundary, or I can, or a boundary along the silhouette around the part, or I can even use flat areas. I'm going to use a 1/2 inch cutter, set my feeds and speeds and clearance, choose the cutting direction, the side direction of cut levels, specify the total depth, and I can also break this up into multiple steps, choose my entry and exit parameters, and then generate, creates a toolpath. Now that we have these operations programmed, I can run a simulation. You can also control the simulation speed in here by increasing the simulation to have it go faster or slower. So there's the simulation of our facing operation, followed by the pocket operations, programming the open pockets, and finally the profile cut. Now, once these operations have been programmed, you can take a look at your estimated machining time, selecting information, gives you the total cutting time, then generate a shop documentation, which allows you to write out a setup information sheet. You can pick from one of these available template types and select save. This would create your setup information sheet, which would make it easier for the machinist on the shop floor to know what the G-code output is intended to do. And you can see it lists the part information, stock material, number of tools used, gives you information about each and every operation that was programmed, and gives you a preview of your display of the cut material simulation. If you had the toolpath visibility on, it would display that as well. And then we're going to do a post process, right click and post. And the posted code will appear in your text editor, which is now ready to be transferred out to your machine tool. Now, saving this file in Rhino will automatically save all of the CAM data in Rhinocam. The same thing applies to all of our other products. If you save the work inside of Solidworks, all your CAM data saves with the Solidworks document. Same thing goes with Libre, and in our Visual CAD CAM, we save it as our Visual CAD CAM format, which is called VCP. So the next thing I'm going to show you is a quick programming workflow in our Visual CAD CAM product here. I'll quickly run through that. The workflow would be very similar to what we did in Rhinocam. So in this case, we could be importing a step IGES or even a 2D drawing for programming 2.5-axis toolpaths. So once you have defined your machine, stock, and aligned it, the next step is to create your toolpath. So we'll go into 2-axis. I'm going to start with a drilling operation. So we'll go into hole machining and drilling. And I'm going to drill these holes by selecting holes on this flat area, on the flat face. We'll pick the tool for drilling, set the feeds and speeds and clearance. And in the cutting parameters, I can specify the drill depth, or I could even measure the drill depth off of the 3D model by just picking 2 points on it. Generate. So we have our drilling operation programmed. The next step is to program the pockets. I'll be using a pocketing operation, and Visual CAM can automatically chain the edges, so you don't have to pick individual edges. Picking an edge automatically auto chains it that are on the same planar area. So we have the pocket selected. We'll pick a tool for it, specify the cutting parameters, your cut patterns, your cut levels, and then finally selecting generate will program the toolpaths. So finally, I'm going to cut the profile on the outside using 2-axis and profiling. We'll pick the outside contour on the part, specify the same tool, choose the cutting parameters, climb cut. We'll determine the side based on the 3D model to cut on the outside, specify our total cut depth. We can choose our entry and exit, generate. Now, if you'd also like to program inside, you can just do a copy paste of the operation, edit the parameters out, drop and pick the inner region, generate the path. So once the toolpath has been generated, we can right click and perform simulation. There's our cut material simulation. So folks, the next thing I'm going to cover here will be multi-axis toolpaths, 3-axis, 4, and 5-axis. And for this, I'm going to be using our Rhinocam module to go over that. So what I got here is a core and a cavity design that was built in Rhino. So we have the cavity, the core, and this is the part that's being produced. And I'll be showing the different toolpath methods that are offered in our 3-axis methods. So the first step is we'll be programming this core feature of the 3D mold. And with our 3-axis toolpaths, we have a wide range of 3-axis machining methods, starting with horizontal roughing, also known as Z-level roughing. So this is a very efficient way to rough out by eliminating all the excessive stock material. And you can control various different parameters, including your step overs, step downs, cut patterns in the roughing process. So you have these controls in the operation parameters where you can specify the step overs, your step downs and the cut levels, and engage in retread and other parameters. Now, once you're through with the roughing process, you can do re-roughing, which is like rest roughing, where you'll be able to go back and rough it out with a smaller tool and not having to cut hair. So this will be able to get into those areas where the previous larger roughing tool was unable to clear the material out. So re-roughing is one of the toolpath methods that's offered in our advanced 3-axis module. And you can go through multiple iterations of the re-roughing process. Now, followed up with different types of finishing strategies. We have finishing methods starting with 3-axis parallel finishing. And as you can see, the 3-axis parallel finishing toolpath, this method is offered in all of our product configurations, the 3-axis parallel finishing. We have several different types of advanced 3-axis methods, like 3D offset pocketing, which is also known as constant 3D step-over pocketing, or also called constant scallop machining. This 3D offset pocketing method is offered with our advanced 3-axis module, available in Pro configurations and above. We have pencil tracing and remachining, which can be used for doing final cleanups, where it automatically identifies bitangencies to generate a pencil tracing toolpath. So you can do a combination of both 2 and 3-axis operation for programming it. So I could select the operation and run a quick simulation here. And there's the roughing process, followed by a facing and a re-roughing process with a smaller tool. And there's our finishing operation, 3-axis parallel finishing. So the 3-axis methods are also offered in all our CAM solutions, Visual CAD CAM, Visual CAM for Solidworks, Libra Camp, and also in our cloud-based product. So the next thing I'm going to cover here is a programming of a multi-axis toolpath. I'm going to be starting with a 4-axis toolpath. We offer both indexed and continuous 4-axis toolpaths. In this demonstration, I'm going to be only covering one of the 4-axis simultaneous toolpath methods that's called 4-axis drive surface machining, also known as true 4-axis machining. So this is a typical part in here, and we've defined a machine tool. You could run machine tool simulations as well for multi-axis toolpaths. And what you're seeing here is a true 4-axis toolpath where the tool remains normal to the surface that's being machined. And I'm going to enable the simulation with the machine tool as well. So the multi-axis toolpath, the 4th-axis toolpaths are available starting with our expert configuration of our mill module. Expert, Pro, and Premium will include 4-axis toolpath methods. And this is the simulation with the machine tool. And you can toggle the machine tool visibility by selecting this toggle button in the simulate window. So I'm going to pause the simulation here. We will now take a look at 5-axis toolpath methods. We do have both indexed as well as simultaneous 5-axis methods. The indexed methods, also known as 3+2 machining, and the indexed 5-axis toolpath methods are available starting with our Pro configuration, and our Premium configuration offers both indexed as well as simultaneous 5-axis machining. Now, here I have an example of a seat design, a seat model. So we would be typically defining the machine tool in here. It could be either a manual definition where you can specify the type of 5-axis machine configuration, a head, table, head, or a table, or you could be using the load from file option to define the machine tool where you can perform machine tool simulation. So what I have here is a roughing operation that's programmed. So that would be a typically like a Z-level roughing or a horizontal roughing toolpath. And you can program it from multiple orientations, so you can have it indexed. So you can rough it out from different orientations. So I'm going to quickly run through the simulation of the roughing toolpath so we could take a look at some of our simultaneous 5-axis toolpath methods in here. So with our premium configuration, you have access to a wide range of 5-axis toolpath methods, starting with curve machining, flow curve, between curve, drive curve, surface normal, and swarf machining methods. What I have programmed here is a 5-axis surface normal, where the tool remains normal to the surface being machined. And let's take a look at a simulation in here. And I'm going to display the machine tool during the simulation. So you can see the rotation of the head on the spindle, the 2 axes, the primary and the secondary axis. And you can toggle the display of the toolpath on and off during simulation as well. So in this 5-axis setup, the 2 rotational axis is on the head, and the parts remain stationary on the machine tool. In the case of a table head configuration, it could be a combination of a rotary table where the part rotates and and the head tilts on the spindle. Or it could be a combination like a table configuration, like a trunnion type of machine tool, where both the rotational axis is on the table where the part rotates. So our CAM products can support all the three different configurations of 5-axis machine tools. So folks, the next module I'm going to be covering here will be our turning module, which is used for programming CNC lathes or turning centers. So for this, I'm going to go ahead and bring in an example where we can take a look at the different types of toolpath methods that are offered in our turning module. Now to load the turning module from the menu, you can select turn, or you can just click the mill icon on your machining browser, and this will switch the interface from mill over to turn. So our turning module has a very similar layout and interface like our mill module. You have the program and the simulate tab on the machining browser and your machining objects browser, which allows you to define different types of tools or turning inserts. We have standard tool types like diamond, triangular, circular, trigon, a wide range of tool and insert types. Similar to our mill module, in the turn module, you can save your tools with the feeds and speeds and save the tools to the library. In turning, we support both per revolution, units per revolution, and units per minute formats as well. There are different types of operations that you can program in turning, starting with roughing, can be done for OD, outer diameter, ID, inner diameter, and also face. Finishing also is available for OD, ID, and face. Groove roughing, groove finishing, follow curve, threading for OD, ID, and parting off as well. So here I have an example of a turning operation where we program turn roughing operations on the face. There's the parameters where you can set in the turn roughing operations. You can choose between the approach type face or OD. We have turn roughing operations for the OD, the finishing operations for outer diameter, roughing operations for the inside diameters. And once we program the grooving operations, you can see the roughing diameter, roughing for the ID features, finishing, and finally the threading operations. I'm going to run a simulation of this in here. And we'll switch. The simulation can be set to either a full or a 3/4 view to make it easier to see both the OD and the ID features in the simulation. And there's your cut material simulation in turning. The turn module is also offered in all of our desktop products, Visual Cad Cam, Rhinocam, Visual Cam for Solidworks, as well as in Libra Camp. The next module I'll be covering here is going to be our nesting module. So nesting module allows us to nest parts into sheets. And in the nesting module, we can work with both solid parts as well as two-dimensional parts. And for this, I'm going to go ahead and bring in this example here, where you can see I have a bunch of solid parts or flat parts that are modeled. It could be modeled in Rhino, or it could be modeled in your CAD system. You can bring them into Rhinocam, or you can work it inside of Visual Cad Cam. So to go from one of the other modules to the nest, you can select the menu at the top and then pick nest, which offers different types of two types of nesting. We have both true shape nesting as well as rectangular nesting. True shape will take the true shape of the geometry in account, and to nest or to pack them into the sheet to basically optimize the number of parts that you can fit into a sheet. So I could either be working with solid geometries like what you're seeing here, or I could be working with just curves like 2D geometry. So you could be selecting these as parts for nesting. So in this example, I'm just going to use solid geometries in here. for nesting. So we'll go with the true shape nesting. We have a wizard interface, so the workflow is very simple and easy to work with. So you basically first pick the type of nesting you'd like to perform. In this case, I'm going to pick true shape. The next step is to click the nesting, select parts, select sheets to nest, and you can either define your sheet by entering in the sheet length, width, length and the height and the thickness, or you can use select curves. If you already had a sheet drawn in your CAD system here, you can just pick that as your sheet, specify the sheet thickness, and you can also set the grain direction and the nesting direction for it. The next step is to pick or select the parts for nesting. Choose select parts. You can drag a window to select all of these parts, and once the parts are listed in here, you have the option to specify the count, which is the quantity, how many of these parts would you like to nest into the sheet. I'm going to put in 10. I can set a priority, so if, you can set the orientation, the grain direction can also be set. And if you'd like to make 10 of all of these parts, I can just say right click and say make all the same. We have 10 of each of these parts to be nested, and it identifies the part and the whole automatically, so it treats each of these as one part geometry. We could specify the orientation. You can mirror parts for nesting, and then finally you would set your parameters for nesting, distance between part to part, part to sheet. You can estimate the number of sheets required in here, and then you can perform the nesting. So I need to make sure I set the number of sheets. I can choose, and then I can choose execute nest, and then basically once I execute the nest, it'll let you go ahead and nest the parts into the sheet in here. So nesting process allows you to nest the parts to your sheet, and once the nesting process is completed, you can preview the sheet, and once the sheets are previewed, you will be able to commit the nest to the sheets as well. So those are the two sheets right there. I'm going to go into the commits nest tab and press commit nest, and this will basically output the sheets as 2 layers, and you can see the sheets are output in each sheet is output in separate layer, and you can export these, or you can go directly from nesting module to our mill module to program toolpaths inside of Rhinocam or in Visual CAD CAM. So this is called parts nesting, where you're basically nesting the parts into a sheet. Now the next module I will be covering here in today's webinar is going to be profile nesting, and we'll talk about what is the difference between parts nesting versus profile nesting. So I'm going to go back and make these layers visible in here. We'll switch from the Rhinocam's nesting module to the profile nesting. Now profile nesting is nesting of profiling toolpaths. So you can generate a profiling toolpath for each of your parts, and you're basically taking the toolpath and nesting the toolpaths into the sheet. So rather than nesting the parts and programming a profiling toolpath, you could program a profile toolpath for each of these parts, and you can nest those profile toolpaths into the sheet. So the profiling operation in the profile nesting module allows you to specify the count and the priority and the number of parts you need. And once you nest them, the profile toolpaths are nested into the sheet. This module is available, profile nesting, in all of our CAM solutions on the desktop side, Visual CAD CAM, Rhinocam, Visual CAM for Solidworks, as well as in Libra Camp with our latest version release. Now, we have a few more modules to cover here in today's webinar. So I will be covering our G-code module as the next one for our webinar today. Now, to cover the G-code module, I will go ahead and load one of these examples in here. So as you can see, I have a part with several toolpaths programs. So you would be typically doing what's called a post process to generate your G-code output. So once the G-code is generated in output, you would want to verify your G-code output before you run it on the machine. So you could be loading the G-code that are generated from MecSoft CAM product or from any other CAM system that you, or any other system that you may have had your G-code. You can bring it into our CAM product. As long as it's in G-code or ISO G-code format, you can load the G-code and run a verification and a simulation of the G-code. Now to switch to the G-code module, you can just select the CAM menu and then select G-code editor, and this automatically displays the interface for your G-code editor. Now we'll go ahead and select load under the projects tab. Go ahead and load the NC file we just generated. And there's our G-code file, and you can see it has 4 different tools. You can always right click and edit to edit the G-code. Before we edit it, let's go ahead and take a simulation in here. I'm going to click simulate, and this shows your verification, a cut material simulation of your actual G-code output that was generated. So this is a brand new module that's offered in our latest version of our products and is available in all of our desktop products, the G-code editor module. Now, if you'd like to make any changes in here, you could always go back to the edit tab. You can look for identifiers, like you can go ahead and identify if you need to set a program number in here, you can specify the program number. You need to look for a tool, right click, and you can search for the tool in here, the next tool number. So it automatically identifies the next tool in here, and you can make changes, and you can see that the editor is automatically shows different types of motion in different colors. The rapids are represented in a certain color, the arc motions, the linear motions, and like you can make changes, you can add additional lines. If you want to merge 2 G-codes, you can do that. So it has all of these utilities built into the G-code editor module. So once you're satisfied with the G-code, you can hit output, and that'll output automatically your posted output file. And there's the modified output where I made a change, where I added the program number to the G-code file. And this is now ready to be transferred out to the controller or your CNC machine tool to cut the part. So this module again is available in all our desktop CAM modules. Now, last but not least, I'm going to be covering some of our CAD modeling tools that are offered in our Visual CAD CAM, and also I'll be covering the art and the mesh modules as well. So I'm going to switch over to our standalone product, Visual CAD CAM, and we'll quickly go over some of the art functionalities. We'll take a look at that, how the art module can be used. Now this module is available both in our Visual CAD CAM as well as inside of our plugin for Rhino. Now to switch the art module from the menu, I'm going to be selecting Visual CAM and art. Now this allows us to take images like bitmap, JPEGs, GIF files, and convert them. We could either do a relief operation or we could do a raster vector. So once the art browser is active, we could go ahead and create relief operations. So I'm going to prep this part here by defining a few curves that can be used for our relief operations as well. Okay, so the first step is to create a project. I can pick origin and extents, and I'm going to pick 2 corners, like how you draw a rectangle. You can specify a resolution for it, and we now have defined a project space. In the next step, I'm going to choose create a 3D relief. Now for this, you could choose any of these 3 supported file formats, bitmap, JPEG, or GIF, and I'm going to pick this dragon image that I have. And I can choose what type of operation to perform, which could be an add, subtract, or unite. So I'll pick add, and you can invert the colors of the grayscale image. You can specify the parameters in here to choose how big or how small of the image you want to place in here. And I'm going to basically snap to these 2 points and give it a height for the relief, and then select generate. So in this process, it's going to create a relief, a 3D relief. When you select the project, you can see that it's merged onto the project. It creates a 3D relief, and the relief has been generated. Now, once the relief has been generated, I can also create reliefs using some of these curves in here. So I can do a puff or a swept volume. So I'm going to use create puffed volume. You can choose from these different available cross-section types. You can also change the cross-sections, specify the type. I'm going to choose add, or I can do a subtract. I'll pick subtract for this example. And I'm going to pick the border curves. I'll pick this and this as my border curve. Right click, again specify the height for it, and then pick generate. Now when I click project, it shows the combined relief. So basically what we did was we created a cavity in here around the outside. Now once you have the relief generated and you're happy with the result, you can select export these as meshes to CAD. So this will export it as a mesh geometry into Visual CAD, or if you're working in Rhino, it'll be as Rhino. You can then program milling operations with it. So you can switch to the mill module, define my stock material in here, then create a 3-axis operation. So I'll pick a 3-axis and a parallel finishing. Pick a tool for it. Specify the parameters. Generate, create your toolpath. So you can go from art to part using the art module, create your reliefs. You can also use the art module for going from raster to vector, by taking an image and convert it to vector geometries. You can select pause, click simulate to end to run through the simulation. The next thing I'm going to be covering here quickly is some of our CAD modeling tools that are offered in Visual CAD. Visual CAD's CAD tools are offered with the Visual CAD Camp product, and these tools are easy to use and can be used for quickly modeling your geometries. So if you go to the Curve Modeling tab, you'll have all access to all of these 2D drawing tools. So for example, if I wanted to create a prismatic part, I'm going to go ahead and define the size of my rectangle. I'm going to create a rectangle that's going to be 8 by 6. We'll add some holes in here. I'll pick the diameter for the hole to be 1/2 inch. And I'm going to go ahead and repeat the same holes using the array command. And I'll specify the distance. We'll make 1 extra copy. So we've arrayed it. We made 4 holes in here. I will go ahead and create a cutout in here by adding a rounded rectangle. We'll specify a radius. And I'm going to use some trim commands to trim these 2 out. I have automatic continuous recall on, so the trim command stays active. And the next step, I'm going to apply some fillets in here. I can specify the radius for the fillet. And finally, I'm going to add a slot in here. So you can use Visual CAD to build your designs. I'll merge all of these curves using the merge command. So we have a 2D model drawn. And finally, I can take this and turn it into a solid. Select all of these curves in our solid modeling tab. I can extrude it and give it a height. We'll extrude it to a 3/4 inch height. And there's your prismatic part now that's ready for programming. And you can view them in multiple viewport layouts. You can resize the viewports. So Visual CAD offers you a wide range of CAD tools, curve modeling, surface modeling, solid modeling, and some of the mesh modeling tools as well. Now, the last module that I'm going to be covering here is called the mesh module. And for this, I'm going to be demoing this module inside of Rhino. We'll use Rhinocam's mesh module to give you a run through of the tools that are available in the mesh module. So for this, I'm going to go ahead and bring in one of these files for the webinar, and we'll take a look at our mesh module. So what I got here is a point cloud data of a 3D scan. And to convert this into a solid geometry, we would need to go from a point cloud to a mesh. So the mesh module can be loaded by selecting mesh from the CAM menu. And this is available both in Rhino as well as in Visual CAD Camp. And the browser interface is very similar to what you've seen in our other modules. So you have create, model, inspect, repair, and if you would like to use it for a 3D printing application, we have tools, utilities for 3D printing. So under the Create tab, the first thing we want to do is take this point cloud and convert it to a mesh. So we have mesh from point cloud. You pick the mesh, and this gives you the controls to create a mesh from point cloud. So selecting Create will generate a mesh from the point cloud data using the mesh creation options that we specified in here. Now, this process could take a few seconds to a few minutes, depending on how complex the point cloud data that you have. And you can see here it's going through the process of creating the mesh from point cloud. Now, once this process has been completed, you will notice that the mesh is now generated. So I'm going to hide the point cloud, and you can see the mesh has been generated. And this mesh has about, as you can see here, close to 1 million triangles on the mesh geometry. Now, there are several holes that you can see that were generated when you did the mesh from point cloud, because some of the points were either missing or not too close enough. So to be able to fix this, we have a utility called AutoFix. AutoFix will automatically identify all the holes. It'll identify the self-intersections and incorrectly oriented normals and triangles, and automatically fix the mesh. So if you try to do this manually, it'll probably take several hours, man-hours to program, to fix these holes. The AutoFix command in the mesh module is a great tool that can automatically fix these holes, self-intersections, and any incorrectly oriented normals in a very reasonable amount of time, which could probably take from a few seconds to maybe a few minutes, or depending on, again, the complexity of the mesh that you're working with. So right now, as you can see, the AutoFix utility is running, and once the AutoFix has been completed, you will notice that the mesh will no longer have any holes. You can see all the holes have been fixed using the AutoFix utility. If I go into a diagnostic run, I can pick the mesh in here and check for open edges. You'll see that there were no issues found, which means the mesh is closed, watertight, which is now ready for downstream applications, should be milling or printing. Now, one of the very commonly used tools is called Decimation, which is basically to reduce the mesh count, and this can be done using the Inspect and Modify tab. This particular mesh, you can see, has close to 1 million triangles now. If I want to reduce it or decimate it, I can use Reduce Mesh, select the mesh geometry, and specify I can either reduce it by a triangle count or by maximum deviation. So in this example, I'm going to choose to reduce it down by 70%. We'll pick Reduce. And in this process, it's going to be reducing the mesh triangle count, down by 70%. So we should be seeing somewhere about close to 300,000 meshes once the mesh has been reduced. And you can see it's down to about 300,000. So Decimation is a very nice, powerful utility that can be used for reducing the mesh count to make it easier for both printing or could be for CNC milling applications. With this, I would like to conclude my part of the demonstration of our CAM modules and hand this back to Anita.
Thank you, Uday. Can we move to our slide? Next slide. Looks like we had a lot of information that was shared by Uday here. We did run out of time, but I'll take a few more minutes to, if you don't mind, to give you details about our products. Now you can evaluate our products very easily. We have, like Uday mentioned, 5 different configurations: the Express, Standard, Expert, Professional, and the Premium. Express is the lowest level, if you will, and obviously the least expensive, and Premium includes goes all the way to 5-axis continuous machining. Our website here provides you a lot of information. First, you can download a demo, take it for a test drive. That's where you would download the demo. You can bring in your part file, run tool paths, simulate an image and see how your part would look. Always talk to us to see how the post-processing would be generated for your router or milling machine. Next, we would also, I can show you exactly where the features per configuration can be accessed. This is again on our website. If you go down to products, pick the product that's suitable for your application and scroll down, you'd see a big old table there that gives you a very detailed description of what machining operations and functionality are included per configuration of our products. We also have a really nice piece of information here. We call it the comparison of our own products. Now, that's on another page on our website. It gives you a really nice table where you can compare each of our solutions, the standalone, the Rhino embedded, Solidworks embedded, a Libra embedded, and our cloud solution with Onshape. So this will give you a nice feel for what is best for my application, what should I pick? And of course, like I keep mentioning, we're always here. We can do one-on-one online demos of our products, and we could do it in a convenient time. So just contact us. We'll get that rolling for you. Next slide, please, Uday. Now, how do we go about helping you once you have the product in-house? We have two ways. Our customer support team is really excellent. You've already heard from our support manager. We have two ways of getting help from our team. One is the annual maintenance subscription that can be purchased at a very nominal price for our products. It gives you the phone, email, login assistance as required. We also offer about 100 tutorials through your customer portal. We call it our Cam Jam tutorials. Very nice. It has been developed in-house and catered to our customers. We do offer training webinars every month, which would be exclusive for our maintenance customers. We release new versions every year, and this is provided at no cost for our maintenance customers. We also have something called the maintenance module, so they spoke about them, the profile nesting, the G-code editor, which is turned on automatically at no additional cost for our maintenance customers. So this is one way of getting help from us. Of course, there's the free support, which would be obviously, not as helpful as our maintenance support, but you do have forum access. You do have a lot of tutorials on our YouTube channel that we enhance pretty much every week sometimes. So that's a really good resource that you can access. Can we go to the next slide today? Now, this brings me to the pricing and purchase of a product. We have an e-store that will give you a very detailed price list, as well as a very convenient way to purchase our products. We have all our different products listed on the left-hand side of the page. You can click on, say, the Visual Cam product if that's what you're interested in, our standalone solution. Each of the configurations can be purchased by clicking on the product and adding it to your cart. You can purchase the maintenance subscription. As you can see, for the standard, it's just $300. Gives you a lot of help and features. This is where you would go and purchase the product. So we go all the way from Express product being $600, Standard $1,500, the Expert $2,500, the Professional $5,000, and the Premium at $10,000. Now we also have the Mesh and the used for 3D printing, obviously, modules that can be purchased separately at $1,000. We have educational products for accredited educational institutes. Now, these are highly discounted. We really believe in helping out our schools and colleges. So you can go to that on our e-store as well. We do have an e-store for our North American customers and for Europe. The pricing accordingly is in US dollars and in euros. So you could use both our websites, e-store, to purchase our products. Of course, if there are any questions, like I keep mentioning, talk to us, sales@mecsoft.com, or call us at any time. Now, we have really had a long webinar today. So we're going to pass on the question and answers panel here, but we will be emailing you with the link to watch this webinar at any time, leisurely, and we will send you the question and answers that were posted, and therefore you won't miss out on that. And again, if you have anything that you would like to talk to us about, just send us an email, call us, we'll take care of it. Okay, next. Now, we have come to the end of it. I thank all of you for taking the time to join us to learn more about our CAM solutions. Call us, fax us, email us, Skype us, chat with us. We are here to work with you. Take care and stay safe.